Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about intervals of increase and decrease.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, y equals a negative 1/5 times, in parentheses, x minus 4 to the 5/3 power minus 2 times x minus 4 to the 2/3 power minus 1, and we have to find all the critical points where the function is discontinuous and where the function is increasing and decreasing. Now, luckily for us, the only issue we could have is the third root that's going on, the 3 in the denominator, the fraction of the exponent. But third root, we're basically fine. It doesn't limit where we can plug in numbers here, so our function is actually continuous everywhere. So we can state that no discontinuities exist. All right, so let's go find our critical points. To do that, we have to find the derivative, and this one's a tricky one. So I'm going to find f prime of x here. Well, f prime of x, again, we're using our power rule. 5/3 comes down, so we have negative 1/5 times a 5/3 times the inside x minus 4, and subtract the exponent by 1, which is a 2/3 now, and then the exponent. Minus 2 times this exponent comes down 2/3. Times, I even forgot, sorry. Just so you know, power rule here. We have 2/3 in the exponent, and then we have to multiply by the derivative of the inside, which is just a 1. I should put that there for you. So again, sorry, 2 here, and then 2/3 comes down, inside x minus 4. To the exponent, 2/3 minus 1 is a negative 1/3, times the derivative inside is just a positive 1. Be careful with that. Alright, so derivative inside is just a 1 there. With that, let's go simplify where we can. We have f prime of x here is equal to 5's cancel. Okay, the 5's cancel there. We have a negative 1/3. So we have a negative out here. 3 is in the denominator. Numerator is still that x minus 4 to the 2/3 power. Minus. All right, now the right side here. We have a 2 times 2 is a 4 in the numerator. We have a 3 in the denominator. Right there, it's left over. Then we have x minus 4 to the negative 1/3 power is the same as the third root in the denominator of x minus 4. Okay, so now this becomes tricky. We need to combine this to be one fraction here. So to do that, I'm going to take this first part and have a common denominator, just like we do with fractions. So I have a negative x minus 4 to the 2/3 power over 3, and I'm going to multiply this by this second part of this denominator. And to make it easier, it's x minus 4 to the 1/3 power over itself. X minus 4, 1/3 power, minus, keep this part the same, 4 over 3, third root of x minus 4. Alright, from there, keep it tricky. And remember, these are the same here, but I did that because it's a little easier to see this multiplication here. F prime of x here. Well, this is where the beauty comes in. We have a negative stays up front. We have x minus 4 to the 2/3 power. That's a 2/3 power, just so you know. And then x minus 4 to the 1/3 power, and it's all combined. We add the exponent to be the 1 power. So we just have an x minus 4 here. Then the denominator stays the same. It's a 3 third root of an x minus 4, just so you can see that. Same thing, same as this denominator, so we can subtract that 4 here in that numerator. Keep going, simplifying this. F prime of x is equal to, good old, we have a negative x up front here now, negative x, and then the negative goes to both parts, making this a negative here, and the x positive of 4, subtract a 4 is 0. We're done, and we have 3 over third root of x minus 4. Okay, we need to find our critical values here. So the critical values, what we want to do is set really the numerator and denominator both equal to 0. All right, we're going to set the whole function equal to 0, but in doing so, we care more about the numerator equal to 0. And so that first part, numerator, negative x equals 0, and that happens at x equals 0. We got one critical point. Denominator equal to 0. Let me break this down a little here. We have 3 third root of x minus 4 equal to 0. Divide both sides by 3, doesn't really matter. Third root x minus 4 equals 0. Don't matter, we take the third power there. Third power is 0, 0. X minus 4 equals 0. And so x equals a positive 4. So we have our two critical points here. my marker doesn't die on me here. I need markers. Critical points are at x equals 0 and a positive 4. So now we make our handy dandy little chart, which I think I can just fit right here. Make sure it's within my range of my writing. We have 0 and 4. And what we're going to do is find values within these intervals here and plug them into our derivative right there. So I want to find f prime of, I picked a -1, and that came out to be a -0.1949. Don't care what the number is, I just care that it's negative, meaning my function is decreasing there. Between 0 and 4, I picked 1, f prime of 1, and that came out to be a 0.23112. Don't care what the number is, I care that it's positive, so we're increasing. Then I want to find f prime of, I picked 5, just bigger than 4, and that came out to be a -1.6 repeating. Don't care the number, I care that it's negative, and we're decreasing. And so now I have my intervals where we're decreasing and increasing here. I can write them out. We're increasing on our interval from 0, my marker doesn't die in the last little bits here, 0 to 4 is a function where we're increasing, and we're decreasing in two parts. Decreasing from a -infinity to 0, and from 4 to positive infinity. And so again, our final answer here, we have no discontinuities exist. Our critical points are x equals 0 and 4. We're increasing from 0 to 4, and we're decreasing from -infinity to 0, and from 4 to positive infinity. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.